Good afternoon, everyone.
Good afternoon. My name is Hussam Mahyo. This is Mohammed Al-Adham and Rita Jaja, my colleagues. Our project today is called My Trainer, which is a wearable gym device. First of all, I just want to ask a question. Who goes to the gym? And who wants to go to the gym? Okay. So going to the gym, you would know that a personal trainer costs a lot of money. So there's no more need to worry about this cost anymore. Because with My Trainer wearable device, you can now have personal trainer around in your hands around the clock.
Okay, so imagine yourself going to the gym around the year, 5 times a day. This can cost up to $10,000 for just the personal trainer. This is too much. What My Trainer does is that it replaces the personal trainer you have at the gym, and it's around the hour in your hand. What it does is that it takes input from the user, like your age, your height, your weight. It calculates your BMI, and it asks you for the level of the workout you want to have. So if you want to have a beginner workout, it's going to be different than the intermediate level. After you choose the workout type you want to have, it's going to suggest a workout for you, and it's going to monitor that workout to make sure you're doing the correct movement in good form. Okay. So as a demo, I'll start now. I'm a mate. Okay. "20 years of age. Yep. Can you see that?
On the camera. On the camera.
Okay. Okay, where's the camera? The camera is here. Okay.
There you go.
Out of focus. Okay, so after you choose your height, it's gonna calculate the BMI. It says I'm normal weight. Hello, champ, I'm your coach. And this is how it goes on. So it says please choose a workout level. I'm gonna choose the, well, beginner. Okay, we're gonna start training. As a workout, we will be doing 3 basic moves, a total of 9 sets. 3 sets of biceps curls, and I'm gonna start them now. Okay, so as we count, 1, 2. This is done using neural networks by machine learning because we provided examples we had before. Okay. So after that, it says it's resting for 30 seconds. Countdown is coming because more than 30 seconds of rest is bad for the muscle. You know, it has to stay warm. And then after 15 seconds, this is funny. It tells you to drink water. You know, it reminds you to hydrate yourself all the time. And then after this is done, so 6 more seconds, just hang on. 3, 2, 1. So it tells you, start your workout again.
Okay, so do the workout.
No, well, the thing is, in 2 days, I don't know how much machine learning you can, as you guys know.
What type of processor are you using?
1 rep. Okay, so still 1 rep. Well, we wish we had more time. You know, machine learning takes ages.
Focus on, yeah, okay.
This is the next stage, and now Hussam is gonna tell you about more technical issues like the neural network we have and all this.
Okay, so we use sensors to read the data from the motion, and then we used artificial intelligence to classify each move. So now we can know that this is a bicep curl or front raise and so on. And then from there it starts counting, and it takes the form of the, it shows you the form of the move, and then it calculates how much error you have or how much you're diverging, because if you're not doing the move right, you're injuring yourself. So to avoid injury, it beeps when you're doing the move wrong.
Okay, so in conclusion, My Trainer can be a perfect replacement for the expensive personal trainer we have. It's a good solution in terms of reliability. It's not just smart, it's a personal trainer, you know. It's not like my Fitbit, you know, the things already exist. It's a personal trainer, and for further development, we can give it much more examples and much more learning time, because machine learning takes time, as you know.
So you can have this anytime, anywhere you want, and with micro technology, we can make it into a bracelet with just a screen, and it's the perfect gym trainer for anyone, anywhere. Thank you.
Thank you for this opportunity. Actually, it's such a great opportunity being here. We learned a lot from the Innovo team. Absolutely.
What processor are you using?
We're using the Arduino Mega because we needed to have more input pins and output pins.
And you mentioned machine learning and neural networks.
Yes.
Yes.
Where does it stand in this?
Sorry.
So
Where does it
it's an
stand?
Arduino. How did you?
Oh, okay.
How
So
did you implement machine learning and the neural
yeah.
networks?
So what we did is we took another يعني an C++. We just tried to make it learn. Like we taught the system to understand these moves. And when the system understands, it gives certain weights, certain values that we can multiply by the data to find out if the move is right and which move it is. So it gives, like, for example, it gives 0, 0 when you multiply it with a certain input. 0, 0 corresponds to bicep curve, for example.
Machine learning is done independently of the Arduino. It's done on the processor of the computer. You provide loads of examples, a huge amount of examples, and then it learns. The output of this learning process is just weights that you use in your Arduino program that's going to tell you if this is the biceps curls or the front raise or the lateral raise or whatsoever. But the number of examples you can give in 2 days is, you know, limited.
Yeah, but so if you have a computer software and you're designing your neural network, let's say, what's the input? What are you inputting? Like what are you designing the neural network on?
We're taking data from the accelerometer, which is X, Y, Z values,
All right.
and then we're squaring and adding each the X values, Y and Z separately. So you have three inputs from there, X, Y, and Z total. So this X, Y, and Z can be used to classify whether it's because it's like a mean, and this mean is used by neural networks to plot the data and establish what type of move it is.
So how many accelerometers you have?
Just one.
We just have one. We can add a gyroscope. It can give a huge amount of accuracy.
Okay, and how can you tell that you're moving your, for example, your elbow wrong right now?
Okay, so if I'm doing it this way,
Yes.
it's a neural. It's called the Euclidean distance.
So there's a center for every move, like a mean, which is the correct
Okay.
move, a perfect move, let's say, which is the mean of all the correct examples that you put. So when you do your move, it checks how far this move is from the correct example. And you have a certain threshold, you know, which is, it's still not incorrect. And then after that, when the error exceeds a certain amount, it starts becoming wrong.
Okay, and how are you calibrating?
We put the accelerometer, actually we calibrate it not on our hand, just on the table and set the values to 0.
You know, a wise thing you can do is if you let a perfect personal trainer do the examples for you. So you know you have the perfect form that you're working on.
Quick question: you calibrated the accelerometers in themselves, putting them on the table. But how do you calibrate the movements? So the reference of the movements. Okay, you have a mean, so the neural network has whatever you call neural network. You have a database that tells you what's the range and from the mean that qualifies in X, Y, Z dimensions. But what's the starting point? So if I'm doing this, or I'm doing this,
but the point is that each of these moves has a different mean X, Y, Z. So it's plotted in a totally different area. So it's not just one mean; it's one mean for each move. So the closest, the move that you're the closest to, is what it's gonna detect, right? So, if it just plots them in different areas, and then it finds which mean it belongs to, and from that mean it finds the error.
Okay, just to say one thing, we have, for this device, we did 4 states. It's the biceps curl, the front raise, the lateral raise, and we did something smart, which is the 4th state. It's called nothing, you know? So you're just doing nothing. It's detecting nothing all the time, unless you do one of these 3 moves.
Then it begins that set. For example, you do a bicep curl, it starts counting for you bicep curls.
I have one question. Anybody else? Okay, last question, hopefully. It's actually in 2 parts. The first part, how did you implement the neural network on an Arduino Mega? Did you write it by hand or did you use a library? And second question is how many layers of
Hardware.
no, neurons do you
hidden
have?
layers.
Yeah, 3
We,
layers?
we have 1 hidden layer and
Alright.
three neurons because we have 3 inputs. So X, Y, Z neurons and 2 outputs because we only have 4 moves. We can increase as much as we want. Sorry, but
The implementation. How did you implement it on
Okay,
Arduino Mega?
so actually, once you have these weights, all it is mathematical calculation. You use a sigmoid function and an exponential and so on to get a certain value, and from there.
Okay, the thing is that Adham, first he did the examples, okay, and then those examples were written in the file on the laptop. We started the learning process on the laptop, not using
No,
the
I
Arduino.
understood
Yeah.
that. But once you get the gains
And
from
then,
the laptop,
once
how
the
do you
learning
implement
is
them?
done, the weights are updated. So we use the updated weights on the Arduino. So it's not learning on the Arduino.
So you write down the
just
mathematical
using the
equations
learning,
that-
yeah,
okay,
the
and
updated
use the
weights
gains.
that classify.
This can be developed into a library, actually. It would have been much easier. Thank you so much, guys. Thank you. Thank you for this opportunity above all. Thank you for being so helpful, Innovo team and the NY.
And thank you, BDL and Innovo.
Cheers, guys. I hope you like it.